this is an example I collected from this pump information from Amazon.com. So if you click on that link that I posted here, it says this came from the Amazon.com. So if you click on that link, you will see this sump pump. Basically, it pumps all the water accumulated under your house and keep the underneath the house dry, so it doesn't get flood. The water doesn't get accumulated and then eventually it's gonna flood. So most houses use sump pump. So the performance criteria is given with the sump pump. So this one says it's a Wayne company pump, and it's a half horsepower sump pump. It delivers about 3,900 gallon per hour at 5 feet head, and then 31.50 gallon per hour 10 feet head. So I use that 3150 at 10 feet head. You could use any of these numbers to analyze this, what's going on with this. So the first thing says, is this statement true? Let's calculate the power based on the information they have provided. So if we want to calculate the power of this pump, the power output according to their number is going to be P. If P is in PSI and then Q is in gallon per minute, then if we divide this by 1714, then this number will eventually come in horsepower. Check the other video how this equation comes. Now for this pressure, it says it developed at 10 feet. Basically, it's a fresh water. So I'm guessing is the feet of water. If they use mercury, that's going to be different situation, but which is 13 times more. Let's see. So that's PSI times the flow rate, which is 52.52 gallon per minute, divided by 1714, which is equal to 0.1326 horsepower. It's definitely not mercury, because mercury is 10 times heavier. This power would be then 10 times. This is 1.31 horsepower, but this pump is only half horsepower. So that's the horsepower is developing, but it claims that it's a half horsepower pump. So I don't know that pump has this low efficiency. Anyway, assume the sump pump statement is true, calculate the horsepower loss. So loss is gonna be, it says that half horsepower pump minus it produces this many horsepower, which is 0.5 minus 0.1326, which is 0.367 horsepower. So mostly everything is lost. Most of the sump pump had just one check valve and just maybe 10 feet of pipe, couple of elbows, which is probably no loss compared to the power. So almost negligible loss in there. The only loss you have is the 10 feet height. Now, then it says find the efficiency. We calculate the efficiency of this pump. It's gonna be the output power divided by the total, it says. So that's gonna be about only 26.54%. I don't know what's going on with this pump, but that's what I got according to their information. Next question is asking if an electric motor is providing half horsepower to the sump pump, maybe they are stating the electric motor pump. Let's calculate that. What is the torque output by the electric motor at 1,000 RPM? So basically, most of these pumps are driven by electric motor. So electric motor that is connected to this pump. So this thing asking you, what's the torque here? So the torque output by the electric motor. So what's that? So if it's in half horsepower, we can just write 0.5 horsepower. We know that equation, torque times rotation divided by 5250. So then this torque will come in pound feet. So if you input this n equal to 1000 RPM and then solve for T, then you get 2.625 pound-foot of torque by the electric motor. Now, it says if this sump pump, next question, delivers maximum, this information also comes from that same website link, you can check that too. If the sump pump delivers a maximum of 42 gallons per hour at efficiency of 90%, what is the theoretical displacement of the pump in cubic inches? So we want to find out that we know that Q theoretical is the volumetric displacement or displacement times the revolution. Displacement usually is per rev and RPM is in per minute, minute per rev. So if you do 4200 gallon per hour, which is the delivery, and then is equal to, I'm just leaving some space so that we, in case we have to convert the units into some relevant one, and then VD, which is typically is in inch cube per rev, but the rev is kind of silent. People just simply say inch cube. That replies that every revolution, how many inch cube of fluid is delivered. So then we have this 2000 RPM, rev per minute. Now we got minute on this side and hour on this side. So we have to convert one of these. We know that 1 hour is 60 minutes. So that is done. Conversion. Now I have to convert this gallons because gallon is a big unit. That's not appropriate for displacement. So we know that 1 gallon is 231 inch cube. So all units are taken care of. So VD, volumetric displacement, is approximately 8 inch cube per rev. However, typically this rev is kind of silent, so you just simply write 8 inch cube. So that's the volumetric displacement of the pump.